Hello everyone, I am Prashant Kumares. My teammates are Rishikesh and Neeraj. So our project is on image segmentation and data abstraction using deep learning under the guidance of Smita ma'am. So abstract. So deep learning is an emerging theme for model recognition and machine learning. The text recognition in pictures is a very important task in a lot of real world applications. The growing usage of invoices and bills has created an unnecessary financial, industrial, labor, and physical resources. So for this purpose, a number of documents have been proposed to fulfill this task. So localizing text from photos taken in the camera with complicated backgrounds is now a growing demand for modern IT services. Most current text localization techniques are sensitive to text features such as color, size, style, and also to the noisy background. A convolutional neural network, which is the CNN model, is used to read the characteristics of each frame. So paper status. So we have currently applied and our paper is accepted in the International Conference of Advances in Software Engineering and Information Technology, that is ICA-CISIT 2022, and our paper is accepted. So this is the mail which we received that the paper is accepted in the conference. So this will be the today's outline: introduction, problem statement, relevance, objectives, proposed system, development, implementation, result, conclusion, and references. So introduction. So recognition of identity document is a special case since they contain the sensitive personal information, and any application should guarantee the security of personal data. The information of the processed image could then be entered into the computer by extracting the primary features of the invoice image and identifying fixed field features. So the main purpose of a system was to determine if the data contained in the invoice line was correct without human supervision. So problem statement. So in today's world, processing images such as invoices and handwritten bills has become an essential process in every sector. We cannot spend time for typing the data into particular form, which leads to waste of time. So we have proposed a solution by creating a lightweight model for the camera captured images, which helps to recognize the text from the image. Relevance of the problem. Since our aim is image segmentation and the extracting the data from the image, that is the invoice image or the bills, using deep learning, all the paper we referred were related to our problem statement. Our motivation is to develop a project that considers invoices with multi-layouts and in an unstructured way and extracts the text efficiently. So objective. So to do image processing, label and find the best way to classify the extracted data under some difficult conditions. The origin image is pre-processed first to remove the useless background information. So we can overcome the problems as the manual data entry is not fast and reliable, as human can do mistakes while copying the data. So proposed system. So overview. So we have the pre-processing invoice, deep learning in the NLP. So nowadays, structure extraction is one of the key research area in the field of deep learning. Hence, we have decided to further proceed with the deep neural network for our case. We have structured this use case in 3 different sections: region detection using deep learning technique, text extraction using OCR tool from the detected region, implement text analytic to identify the relation between the extracted text and the dump it into the repository. So image pre-processing. Here the images are being prepared for training and testing process. Once all the images are collected and processed, it will be passed for training to the deep learning models. Structure extraction using deep learning. So we have divided the extraction part into 2 categories. So detection modeling and text extraction. Detection modeling, we will pass the dataset to the detection model in order to identify the tables or the paragraphs and the forms in the input images. We have used OLO model for final use case. Text extraction. The next component in the pipeline is text extraction. We are currently working with the open source OCR tool named Tesseract OCR for text extraction from the detected regions. So development tools will be continued by my friend.
Hello everyone, I am Rishikesh Padibat. Thank you Prashant for giving a brief introduction of the project. I will continue with the development tools that are used in the project. The software development tools that are used in the project are: first is programming language, that is Python. The different libraries and modules that are used are Tesseract, OCR, TensorFlow, Augmentor, Pillow, Globe. The ID that we are using is Jupyter Notebook and Google Colab. Next is the algorithm of our project. Algorithm mainly consists of two steps. The first step is detection modeling. In the detection modeling step, once the data set is ready, we will pass the same to the detection model in order to identify the tables, paragraph, and forms in the input images. In this project, we are making use of YOLO V5 model in order to detect the region in the images. YOLO. The YOLO is an acronym that stands for You Only Look Once. We are employing version 5, which was launched by Ultralytics in June 2020 and is now the most advanced object identification algorithm available. In the YOLO object detection model, the approach that is used is single neural network to process the entire picture, then separates it into parts and predicts bounding boxes and probabilities for each component. It then delivers detected items after non-max separation. Text extraction is the next component in the pipeline. We are making use of Tesseract OCR in order to extract the text from the detected regions that is given by the YOLO model. Tesseract. Tesseract OCR recognizes the text content of an image and converts the image into machine-coded text that can be processed by a computer. Next is the implementation part. The implementation part first starts with the preparation of training dataset. Approximately 1,000 images were collected from various sources, including Google and some other supplier invoices, and 30% of the images were stored for model testing and validation. Image enhancement techniques have been introduced to improve the accuracy of the model. The first step in the preparation of training dataset is image normalization. Image normalization techniques are used to change the range of pixel intensity values to improve image contrast. Histogram equalization or contrast stretching mechanisms are often used to normalize images. In this use case, we use the contrast stretch technique. We have trained a deep neural network with an image size of 600 cross 600 pixels. We have used the resizing feature of PIL Python, that is Pillow library of Python, to resize the image. The next step in the preparation of training data set is image augmentation. To work well with deep meshes, you need a lot of data for training. Since we collected only 950 images, we used image enhancement technology to improve network performance. The Python library augmenter helped to generate extended images along with the movement of the bounding box. Augmenter is a Python package developed to support image data extension and artificial generation for machine learning tasks. This is primarily a data extension tool, but it also includes basic image pre-processing capabilities. This is the code that is used to augment the images. The code consists of to augment the images by making use like zoom in, zoom out, and flipping top bottom, increasing the brightness, decreasing the brightness, rotating the images. And this is the original image. This is a sample of image augmentation. This is the original image. These are the augmented images. The first one is with the affine transformation. Second one is brightness. And the third one is Gaussian blur. And the fourth one is horizontal flip. So the next part will be continued by the Neeraj.
Hello everyone, myself Neeraj. So we have used a Google Colab for model building. So I will explain the code for model building. So initially, first we have to mount a Google Drive. So this is the code for the Google Drive, and this ls my drive will list out all the documents which is present in our drive. So that's the result which will tell us the Google Drive is mounted. So before that, we have to also include the data set to the drive, and here we have already included the data set to the Google Drive, and as you can see, it's the output is train and valid. Means we have already distributed the data sets to test and train. So after that, we have to change the directory to the YOLO-UEFI, and in that YOLO-UEFI, we have to clone the YOLO-UEFI repositories. So this is a link for that YOLO-UEFI, and after cloning, we have to change our directory to the YOLO-UEFI and install the dependencies. All the dependencies will be in the requirements.txt file. So using pip install, we can install all the dependencies that are required for the YOLO-UEFI. So before running the or before training the YOLO-UEFI model, we have to open the Coco 128.yml file that is present in the data file. I will show that file. So this is the Coco 128.yml file. Here we have to give the train images path and the test images path. And also we have to change the number of classes. Here we are identifying only 2 classes. So we have given the 2 as a number of classes, and we have to give the name of a classes also. So we have given paragraph and table as a class name, and after that we have to save this file. So after doing that, we are ready to we are good to train the model. So this is the code for the training the model. Here train.py is already present in the YOLO-UEFI, and this image is the 600 is the image size, and batch is the 8 we have given, and for epochs 100 we have trained it, and this is the path of the Coco 128 YML file. And we have used the YOLO-FIS pre-trained model, and there are many pre-trained models. We can also use that. And after that, we can visualize the training matrix using TensorBoard. So this is the code for that. So here we can get all the matrix graph and the train graph also. So this is the output of the TensorBoard, and this is the code for the testing. So here we are using val.py file, which is already present in the YOLO-UEFI folder. So same after training the model weights will be saved in the train folder. So we have to just copy that path and just paste it here, and give the image size that is 600, and also the data file that is YML file. After training, the results will be stored in the runs folder. And if you want to detect the new image, for example, I will show you one example. So this is the image we are going to detect it. So this is the image we are going to detect it. I will just copy the path of this and paste it here. And we have to run this. So it will take time, and the results will be stored in the runs folder. So let me open the runs folder, and in runs folder detect, and in the exp16 it will be stored. You have to just refresh the folder. So here exp16 and invoice 46. So this is the result of the detecting the new images. Here the model will detect the paragraph and table images, and these images will be stored in the stored like in separate folders like paragraph and table. As you can see here, paragraph table has all the paragraphs images, and table has all the table images. So after this, we are going to use the PyTesseract for extracting the text from these images. So to install, we have to install the PyTesseract. So this is a pip install PyTesseract is the command for that. And after that, we have to import libraries which are used by this for extracting the texts. and we have to check the tesseract where it is installed and paste that path in this command. So after that, in this we have to paste that image which we want to extract the text. For example, we are going to extract this $4520 from this. So we are going to copy this path and paste it here. And if we run, it will load. And if we print that, the result will be text will be extracted from that image, that is 4520. So this is the project. So next, so since we have, as you can see, we have used a YOLO v5 model for object detection, that is class and class like paragraph and table will be detected, and these images will be stored in the crop folder. Like paragraph and table images are cropped and stored in the separate folder. So for these images, we have used OCR, tesseract OCR, to extract the text from that. So as you can see, this is the screenshot of the result. So this is the paragraph and tables are identified from the invoices. And this is the text extracted from the invoices. That is, we have extracted the bill amount, total bill amount. So we have explored all the variety of state of deep neural networks. And we have came across many object detection model like FRCNN and RCNN also. So we thought of to continue with the YOLO based on this accuracy and the time complexity. And for future work, we are going to use the graph neural networks to build a relation between to better handle and improve the relation between the table headers, rows, and cells also. So these are the references we have gone through. Thank you.